The genetic code hidden inside your chicken's earlobes and why it changes everything. You probably walked past a carton of eggs this week without thinking about the tiny red marks printed on the shell. Those stamps, the ones that look like a farmer's code or a factory identifier, are not in fact the whole story. The real secret is older than modern farming. It's written in the chicken's genetics and expressed in a place you've never paid attention to. And here's what I need you to know before we go further. By the end of this video, you'll understand why the egg industry's entire color system is built on a biological lie about what those earlobes really mean. Stay with me, because that revelation will change how you read every carton you buy. Most people assume that chicken breed determines egg color. That's the first mistake. The second is thinking the lobe color tells you anything reliable about the bird's health, diet, or the quality of what it produces. Neither assumption is entirely wrong. Both are incomplete. And that incompleteness has been weaponized by marketing for more than 60 years. Here's what actually happens. Chickens inherit genes that code for pigment production in two separate systems. One affects the shell itself, the calcium carbonate coating that hardens over 18 to 20 hours as the egg moves through the oviduct. The other affects the earlobe. Yes, chickens have earlobes. They're called wattles when they hang beneath the chin, but those little lobes beside the head, those are the visible earlobes, and they're a direct genetic expression of one specific trait. Wait, this part is important. The genes that control earlobe pigmentation are not the same genes that control shell pigmentation. This is the gap where the entire deception lives. In the 1950s, American egg producers noticed something. Chickens with red earlobes, a trait inherited from specific breeds like the Rhode Island Red and the New Hampshire, consistently laid darker eggs. Chickens with white earlobes, often from breeds like the Leghorn, consistently laid white eggs. For decades, this correlation felt causal. Consumers began to believe that the earlobe color was a guarantee. A chicken with a red lobe meant a brown egg meant higher quality, higher omega-3, more natural, more wholesome. Marketing departments did not correct this mistake. They reinforced it. The problem is this. You can take a chicken with a red earlobe and feed it the exact same diet as a chicken with a white earlobe. You can house them in identical conditions. You can breed them selectively for egg production. And the correlation between lobe color and shell color will hold, but not because the lobe color causes the shell color. They're both downstream expressions of the same genetic block. The lobe is just visible from the outside. The shell pigmentation gene is inside, in the cells of the uterus. What matters infinitely more than either is this. The pigment that colors the shell, whether it's brown or white, is almost entirely cosmetic. A 1980s U.S. Department of Agriculture study examined hundreds of eggs from both brown and white egg-laying breeds, controlled for diet, breed, and age. The nutritional content was nearly identical. The only meaningful difference was the shell itself. Brown shells tend to be slightly thicker due to the calcium deposition that occurs when pigment is being laid down. Thicker shell means slightly less air exposure during storage. That's the entire difference. Not nutrition, not quality, not the health of the chicken, shell thickness. The genetic code hidden inside the chicken's earlobe tells you something, yes. It tells you which ancestral breeds were selected for. It tells you about pigment production at the cellular level. It tells you about selective breeding patterns across a century, but it does not tell you whether that chicken ate better, lived better, or produced a better egg. This is where the industry's math becomes truly interesting. A brown egg in most American grocery stores costs between 20 and 40 cents more than a white egg. That price difference exists almost entirely because consumers believe the earlobe story. They believe red lobes mean something, and for more than half a century, no one in the supply chain corrected them. Farmers don't correct them because brown eggs command higher prices. Retailers don't correct them because they benefit from the margin. Egg boards, the state-level marketing organizations funded by producers, have spent millions cementing the association through advertising that never once mentions genetics or explains what an earlobe actually signifies. If you've ever left a comment on a recipe video or a grocery haul about preferring brown eggs, I'd genuinely love to know why in the comments, not to judge you, to understand what story you believed about it. And if you haven't subscribed yet, this is the kind of hidden logic that runs through dozens of products in your kitchen. The channel goes deep into these exact moments where marketing and biology intersect in ways that affect your wallet and your choices every single week. So here's where the system gets interesting. The earlobe doesn't just predict egg color. It predicts chicken breed. And breed determines everything else: how much feed that bird consumes, how long it lives, how efficiently it converts grain into protein. Those variables ripple outward through feed mills, processing plants, and ultimately your grocery receipt. Rhode Island Reds, which carry the brown egg genetics, tend to be larger birds with higher feed requirements than the Leghorns that lay white eggs. A Rhode Island Red will eat roughly 120 pounds of feed in a year. A Leghorn will eat closer to 90. That's a 33% difference. Multiply that across millions of birds, and the feed cost differential becomes substantial. Feed represents 60 to 70% of a commercial layer operation's total expenses. So the moment a farmer selects for brown eggs, he's inadvertently selecting for higher input costs. Yet the retail market has accepted, even expected, a price premium for brown eggs for decades. The markup sits somewhere between 15 and 30% depending on region and season. In some markets, brown eggs cost $2 more per dozen than white eggs. The nutritional content is identical. The taste is identical. The only difference is the pigment deposited onto the shell by a bird's pigmented earlobes. Here's what I need you to really sit with for a moment. That price differential doesn't reflect biology. It reflects a belief. And beliefs are powerful in retail because they're self-reinforcing. Once enough consumers accept that brown is better, retailers stock more brown, farmers breed more brown layers, feed suppliers invest in the genetics and marketing that support brown breeds. The system locks into place. The state egg boards have been very effective at this lock. The California Egg Commission, the Michigan Egg Board, the Texas Poultry Federation, these aren't consumer organizations. They're funded directly by producers and have budgets sometimes exceeding $2 million annually. Their purpose is to increase demand and stabilize prices. One of their most successful strategies has been to frame brown eggs as the premium, traditional, or more natural option. A California Egg Commission campaign from 1985 used the slogan, "The Incredible Edible Egg," paired with images of pastoral farms and brown eggs basking in sunlight. No mention of genetics. No mention of earlobes. Just the suggestion that brown equals authentic. That campaign ran for years and shaped an entire generation's purchasing behavior. The irony is that if you wanted to eat an egg from a traditional or natural bird, you'd probably be more likely to end up with a white egg. The Leghorn, a Mediterranean breed that's been domesticated for over 200 years, is arguably more established in Western agriculture than the Rhode Island Red, but the Leghorn lays white eggs, and white eggs over the past 50 years have been repositioned as industrial, mass-produced, and less desirable. Before we continue, I need you to keep something critical in mind. This isn't a story about deception in the conventional sense. No one at the egg board is lying about earlobes. The connection between earlobe color and shell color is absolutely real. The deception, if you want to call it that, is one of omission and framing. They've simply chosen never to educate the consumer about the mechanism. They've let the superstition live, because the superstition is profitable. That's the design decision that most people never trace back. The farmer isn't trying to deceive you when he sells brown eggs at a premium. He's operating in a system where his buyers expect to pay more. The retailer isn't deceiving you when he shelves brown eggs at eye level and white eggs lower down. He's responding to demand shaped by marketing that happened decades ago. Everyone in the chain is acting rationally within a belief system that no one has bothered to interrogate. And here's what makes this genuinely interesting from an engineering perspective. The pigment system that colors the earlobe is beautifully efficient. It's controlled by a small set of genes that produce melanin and xanthophyll compounds. The bird doesn't need to expend extra energy to create that pigment. It's a byproduct of the same pigmentation pathways that color feathers and skin. So there's no biological cost to having a brown earlobe. The trait spread because breeders selected for it, not because it conveyed any survival advantage. In fact, if you examine the actual genetics, brown egg breeds often come with trade-offs that have nothing to do with the egg itself. They're sometimes more susceptible to certain diseases. They can be more aggressive in confined settings. They require more space and more careful management. But none of that information makes it to the consumer. The earlobe color remains the only visible cue, and it's been marketed as sufficient. The result is a market structure that has persisted for 50-plus years based on a single, visible trait that has no bearing on the product's actual quality or nutritional value. That's not an accident. That's a design. Someone somewhere decided that the earlobe was the perfect proxy for premium because it's visible, memorable, and tied to a biological mechanism most people would never bother to understand. The problem is that this design has consequences that ripple far beyond the farm gate. Once you've told people that brown equals better, you've created a permanent economic hierarchy, and that hierarchy gets reinforced at every step of the supply chain, from the hatchery to the checkout counter. Consider what happens inside an industrial hatchery. A facility processing 500,000 chicks per day doesn't have time for nuance. Brown egg breeds are separated from white egg breeds before they even fully hatch. The chicks are sorted by feather color, eye color, and earlobe color, the same visible traits that will determine their market value. A female chick with the right genetics gets placed in one facility, a male chick gets placed in another. And if a chick doesn't match the expected physical profile, it gets culled immediately. Thousands of them, every single day, because they don't meet the visual standard that consumers will eventually see on the shelf. This sorting process isn't about biology anymore, it's about appearance. A brown egg breed is selected for one trait, the color of its earlobe, and that single criterion determines whether it lives or dies on day one of its life. That's how powerful the original design decision has become. Wait, hold on. Before we continue, I need you to understand something crucial about how markets reinforce these decisions. It's not enough to have a product. You need consumers to believe in it. And belief requires consistency. Every brown egg carton you've ever seen has looked roughly the same for the last 50 years. Every package has communicated the same message. Premium, natural, worth the extra dollar per dozen. That consistency is deliberate. It's part of a larger design system. Marketing agencies, grocery chains, and farm cooperatives all work together, whether consciously or not, to make sure that your mental image of a real egg matches what you see on the shelf. The farm on the carton never shows an industrial operation. It shows a cottage, a fence, maybe a rooster. Those illustrations are so consistent across brands that they've essentially created a shared fiction about where eggs come from. And that fiction changes purchasing behavior. Research from agricultural economics programs has shown that consumers will pay significantly more for brown eggs, specifically because the packaging and marketing have convinced them that brown eggs represent a particular kind of farming, a more ethical kind, a more natural kind. But the hen's earlobe has nothing to do with ethics or naturalness. It's purely aesthetic. It's purely marketing. The design works so well because the consumer has never been shown the hatchery floor. They've never seen the culling process. They've never had to confront the fact that their choice between brown and white is in many cases a choice between two equally industrial operations with one cosmetic difference. This is where the design becomes almost insidious. The earlobe color isn't just a biological trait. It's the perfect marketing tool because it solves a problem that the egg industry faced decades ago. How do you convince consumers that your product is premium when the actual product, the egg itself, is chemically identical to the cheaper option next to it? You can't change the protein content. You can't change the taste in any meaningful way. You can't change the nutritional density. What you can do is make one type visually distinct. Give it a color. Give it an identity. Give it a story. The story is the design. The earlobe is just the symbol that carries it. And this is exactly why the story stuck. A farmer in Iowa didn't decide one morning to breed chickens with colored earlobes because he wanted better eggs. He did it because consumers were willing to pay more for something that looked different. The visual difference became the entire value proposition. Not taste, not nutrition, not how the chicken was raised. The color. By the 1950s, brown eggs had become synonymous with rural authenticity, with small-scale farming, with a kind of pastoral integrity that white eggs simply couldn't claim. Marketers didn't invent that association from nothing. They recognized it was already forming in people's minds, and then they accelerated it. They printed it on packaging. They told stories about heritage breeds. They positioned brown eggs as the thinking person's choice, the ethical choice, the choice made by someone who actually cared where their food came from. White eggs, meanwhile, became the industrial default, the commodity, the thing you bought when price mattered more than principle. Here's what matters. The actual genetics of earlobe color has no bearing on any of this. A leghorn hen with white earlobes can be raised on a small, high-welfare farm using best practices. A Rhode Island red with red earlobes can come from an industrial facility with minimal space per bird. The earlobe tells you the breed. It tells you nothing about how that breed was treated, what it was fed, or what kind of operation produced the egg inside. Yet consumers, and I mean this without judgment because the system was designed to exploit exactly this impulse, consumers began treating earlobe color as if it were a window into the chicken's life. Brown eggs became a proxy for good. White eggs became a proxy for industrial. Before we continue, I need you to sit with this for a moment. This is the moment where design theory intersects with consumer psychology in a way that's almost uncomfortably efficient. A trait that emerged from selective breeding for egg production became a visual marker. That visual marker became a story. That story became a willingness to pay a premium. And the entire system was built on the assumption that most people would never know that the earlobe color came from the chicken's genetics, not from how it lived or what it ate. The design isn't in the egg. It never was. The design is in the market perception that surrounds the egg, and that perception was built deliberately, methodically, over decades, on top of a biological accident. Geneticists can tell you exactly why this happens. The gene that codes for earlobe color is linked, on the same chromosome, to the genes that influence egg production capacity. When breeders selected for higher-laying hens, they were inadvertently selecting for certain earlobe colors. The chickens that laid more eggs happened to have darker earlobes. So, darker earlobes became associated with productivity, and then marketers took that association and transformed it into something consumers could feel virtuous about. The thing that still bothers me about all of this is how perfectly it works. How a trait that has absolutely nothing to do with egg quality or animal welfare became the single most visible indicator of both in the consumer's mind. Walk into any grocery store in America, and the earlobe color of a chicken you've never seen will influence your decision in the produce section. It will change what you spend. It will change which farms get funded to expand. It will change which breeding lines survive into the next generation. All because of something the chicken had no say in. And here's where the economics get strange. That association between darker earlobes and productivity wasn't created by accident. It was engineered. Once breeders realized the correlation existed, they didn't just passively observe it. They actively strengthened it. Every generation of selective breeding pushed the trait harder. Darker earlobes became the visible badge of a high-producing bird. Poultry genetics companies built entire marketing campaigns around it. The consumer never learned about the genetics. They learned a simple rule. Brown eggs come from brown hens, and brown hens are somehow better, superior, more natural, healthier. None of that is technically false, but none of it is because of the earlobe color itself. The earlobe is just a window into breeding intensity, a visible marker of how hard these birds have been pushed to produce more. Before we continue, I need you to hold on to something. The real story here isn't about chicken genetics. It's about how we use visible traits to make invisible decisions. Every time you stand at the grocery store, you're not actually choosing based on biology. You're choosing based on a signal, a marker that someone else has already decided means quality. And that signal is only as reliable as the system that created it. The poultry industry knows this. They've known it for decades. In fact, the connection between earlobe color and perceived quality is so strong that it's been weaponized in marketing. Premium brands make a point of showing you the brown hens. Free-range producers photograph brown eggs. Organic certification bodies often favor brown breeds because consumers expect it. The brown earlobe became shorthand for everything the industry wanted consumers to believe they were buying. But here's what most producers won't tell you. A white egg-laying hen can be raised in identical conditions to a brown egg-laying hen. She can live the same life, eat the same food, receive the same amount of sunlight and space. The only difference is the genes that control earlobe pigmentation. And those genes, in most modern breeds, ride alongside other genes that influence overall productivity. It's not magic. It's not some hidden property of the brown egg itself. It's genetics bundled together by humans for humans. The melanin that creates the dark color in a brown hen's earlobes is the same melanin that appears in human skin. It's a protective protein. In chickens, it serves no known biological function in the earlobe itself. But the genes that produce that melanin are located near the genes that control reproductive cycling. When breeders selected for one, they were pulling along the other. It's a genetic hitchhiker. This matters because it means the signal has become disconnected from what it supposedly represents. You can now breed a white egg-laying hen with excellent health and productivity. You can raise her in the best possible conditions. But she'll never have the earlobe color that signals quality to the American consumer. So she'll never command the same price. She'll never be featured in marketing. She'll never become the standard for premium eggs. The market has essentially locked in a preference based on a visible genetic marker that has no functional relationship to what consumers think they're buying. It's elegant, really. It's also a perfect example of how design decisions, even biological design decisions made by breeders, propagate through entire systems. A choice made in a hatchery in Iowa ripples outward to influence what appears on shelves in New York, what gets funding, what gets bred out of existence. Your grandmother didn't have access to brown eggs. They didn't become commercially available in America until the 1970s. Before that, white eggs were the standard. They were cheap, efficient, and nobody questioned them. Then, as selective breeding intensified and certain breeds became associated with higher output, the colors shifted. The market shifted with it. Now, brown eggs represent quality in the American mind so thoroughly that the reverse, white eggs as premium, seems almost absurd. That reversal actually exists in other countries. In parts of Europe, white eggs are still the default. In some regions, they're considered the superior choice. Same chicken, same eggshell, different cultural signal, different genetic preference, different price point. The decision to breed certain traits got locked into the physical body of animals that depend on humans for reproduction. And once those traits were locked in, the market organized itself around the signal. Consumers organized their preferences around it. Farms organized their production around it. And nobody ever had to convince anyone that it mattered because they could just see it. This is where the engineering becomes social. The trait itself, the color of the eggshell, carries zero biological weight. It tells you nothing about nutrition. It tells you nothing about taste. It tells you nothing about how the chicken was treated or what it ate. But it became the primary decision point for millions of purchases every single week. Farmers didn't just breed these traits for themselves. They bred them because the market demanded them. And the market demanded them because the market saw them. Visibility became biology. Signal became selection pressure. A color that originally meant nothing, just a genetic variation, became a reason to choose one chicken's offspring over another's, generation after generation after generation. The earlobe color works the same way. When breeders decided that earlobe color could reliably predict egg color, they created a shortcut, a visual signal that farmers could use to identify which birds to keep and which to remove before they'd even laid their first egg. That saves time. That saves space. That saves money on feed for birds you're going to cull anyway. But here's where this gets complicated, and I need your full attention for a second, because this is the part that reveals how deeply genetics and human choice become tangled. The correlation between earlobe color and egg color isn't absolute. It's statistical. A chicken with white earlobes will very likely lay white eggs, but very likely isn't the same as guaranteed. Some birds break the pattern. Some white-eared birds lay brown eggs. Some brown-eared birds lay white eggs. The variation exists because genetics isn't a simple switch. It's a probability distribution. Farmers and breeders know this. They've always known it. So what they did was breed selectively not just for the trait, but for the reliability of the trait. They kept breeding birds that had the most consistent correlation between earlobe color and egg color, and they culled the exceptions. Over many generations, they tightened the link. They made the correlation so strong that a farmer could look at a day-old chick's earlobes and predict its egg color with better than 95% accuracy. That's not magic. That's not a perfectly encoded system. That's the result of thousands of individual decisions made by thousands of people, each choosing to keep or remove a bird based on how closely it matched an ideal. And because that system worked so efficiently, it became locked in. Hatcheries standardized around it. Farmer cooperatives built their entire production schedules around it. The genetic code that controls earlobe color became inseparable from the genetic code that controls egg color, not because they're the same gene, they're not, but because human selection made them act like they are. This is the secret I promised you at the beginning. The earlobe isn't just a visual signal. It's proof that selective breeding can create correlations so tight that a trait that originated as pure coincidence becomes practically biological law. The chicken inherited a color code written not by evolution but by human preference, and that preference reshaped the genetics so thoroughly that the signal became reliable enough to use as a production tool. Every egg you buy at the grocery store carries this history inside its shell, not written into calcium, not visible under a microscope, but written in the sequence of decisions that determined which birds would reproduce and which would not, written in the genetic preferences of thousands of farmers working independently, all making the same choice because the system rewarded it. The chicken's body became a language, and we learned to read it. This is the secret I promised you at the beginning. The earlobe isn't just a biological accident. It's the physical evidence of a decision we made as a species about which animals deserve to survive and reproduce. Every chicken alive today, the billions of them in farms across North America, Europe, Asia, they are the descendants of birds whose earlobes match the color we decided to prefer. That tiny flap of skin is a living record of industrial preference written into DNA. And here's what makes it matter. You've been making the same choice every time you opened your refrigerator. The system didn't stop with earlobes. Once we proved that visible markers could reliably predict production, poultry genetics accelerated. Body size, egg-laying frequency, meat conversion rate, feed efficiency. Every trait you see in a modern chicken, the oversized breast, the accelerated growth, the ability to lay eggs year-round without rest, none of it would exist if we hadn't first learned to read the earlobe. Breeders started selecting for birds with larger earlobes, not because bigger earlobes made better chickens, but because larger earlobes correlated with better layers. The earlobe became a sorting tool, a barcode written in flesh, and within 3 generations the signal was strong enough to depend on. The implications spread quietly through the industry. If you could predict performance from a physical marker, you could organize entire breeding programs around it. You could move away from guesswork and toward logistics. You could make breeding predictable. That's the true genius of the earlobe story. It wasn't the discovery that genetics and appearance were linked. Darwin knew that centuries ago. The innovation was recognizing that you could use one visible, easy-to-measure trait as a shortcut to selecting for invisible traits you actually cared about: production, efficiency, profit. Modern poultry genetics doesn't work the way most people imagine. They're not running blood tests or analyzing DNA sequences. That technology is too slow, too expensive, too unreliable for the scale of what's happening. Instead, they're still using shortcuts, physical markers, body proportions, growth rates at specific ages, all of it built on the principle the earlobe taught us: make the invisible visible through correlation. A chicken's leg strength predicts skeletal integrity. Its body weight gain in the first 6 weeks predicts mature production capacity. Its beak pigmentation, its actual pigmentation, correlates with intestinal health. None of these are direct causes. They're all signals, markers, shortcuts that work because we've spent 70 years breeding birds where these correlations hold true. The earlobe changed farming from an art into a process, from intuition into logistics, and frankly that terrifies some people. They see the modern chicken, the one with the enormous breast that struggles to walk, and they assume it's all been wrong, that we've optimized ourselves into a corner. But the system isn't broken. It's working exactly as it was designed to work. We wanted chickens that laid more eggs faster. We got them. We wanted meat birds that grew to slaughter weight in half the time. We got them. The earlobe color didn't cause those outcomes. The earlobe was just the first tool we used to make selection systematic, to scale it, to industrialize it. Every choice had a consequence. Every selection created trade-offs. Faster growth came with skeletal stress. Accelerated egg production came with calcium depletion. Larger body size came with reduced mobility. We made those trades because the market rewarded us for maximizing one metric: production per unit of cost. The earlobe is still there, still white or red or pale, still correlating with performance in ways we've reinforced through 100 generations of selection. But it's no longer the bottleneck it used to be. Modern birds carry genetic markers we can't see, traits so refined that a single chicken might carry the cumulative effect of decisions made by thousands of breeders across continents and decades. Here's what I want you to sit with this week. The next time you buy eggs, look at the color. Not because brown eggs are healthier, they're nutritionally identical to white eggs, incidentally. Look at them, because that color choice represents a moment when humans decided which animals deserve to exist, and we made that decision based on an earlobe. We're still making those decisions. Every time we reward efficiency, every time we choose the cheaper option, every time we demand chickens that grow faster or produce more, we're casting a vote for a particular genetic future. The earlobe was just the first language we learned to read. The birds are speaking. We learned to listen. Thank you for watching. If you want more stories about the hidden engineering inside the things you use every day, please subscribe and ring that notification bell so you don't miss a single one. I'd love to know in the comments, what everyday object do you want to understand better? Your suggestion might be our next video.